All right, welcome to Unit 3 here. Unit 3 is all about systems of equations and inequalities. 3.1, we're going to start off basic here with some systems of equations. We're going to solve them by substitution or elimination. We'll get some definitions here, some kind of examples, and so on. This shouldn't be too bad. The substitution you should have done before in actually, and elimination as well in Algebra 1. So this should be a quick review. Hopefully. Definition. So a systems of equations. So I'm gonna define a system of equations right there. Basically, what it is it's two or more systems. We'll do this. Two or more equations. There we go. There we go. That makes more sense. Two or more equations solved simultaneously. Simultaneously. I know my spelling is kind of atrocious in my handwriting, but actually it's spelled correctly. But simultaneously, that means that both systems will be or both equations will be solved at the same exact time, meaning the point that we get for our answer will solve both of them. Okay. Now, next thing is, how is the answer written? So when I'm solving just a problem, so like basic skill work, okay, basic skill, my answer is going to be in an ordered pair, x comma y. Whatever x is, whatever y is. Now, it might not always be x and y. It could be like r and s, or u and v and stuff like that. But I'll kind of get, when we have examples like that, I'll show you. When we have some word problems, you're going to spell it out. So it would be x equals blank, however much numbers per hour or dollars per hour. You're going to spell it out with units. So with word problems, it's with units, okay, and the y as well, okay. You're going to spell it out. You're not going to just put it in a parentheses. And how do I know where to find the answer? So if you were given a graph and you had two lines that kind of touch, where the answer is where they touch. All right. That's what we're looking for. That's when we solve a system. That exact point in time is what we're trying to find. And we'll get through some different strategies, substitution, elimination, and so on for the rest of this unit. So substitution. Just like you, I don't know, maybe the word substitution rings a bell. We've used this word before. It's best when one variable can be isolated easily. So it's best be used when y equals something or x equals something. So if you can get a y equals by itself really fast, or x equals by itself really fast, then this is the one for you. Okay, this is the one for you. Elimination is when the variables line up easy. What does that mean? That means that I have like x plus y equals a number, and then another, I don't know, 5x plus 6y equals another number. They're lined up right there easily. Therefore, I can use elimination. We'll talk about that, what that looks like here as well. Now, it is uh, hopefully known, and whether it's right or wrong, it's not really wrong, I guess, but I do want you to understand that both of them can be used to solve a linear equation like a system, but one will always be a better choice. Better means faster in this case. Okay, better means faster. You can solve them both, using both methods, but one will be faster and one will take you 4 or 5 times longer. It's kind of your job to identify which one is easier to use. So let's get into substitution. Now, on the right here, you have some kind of general steps to follow for substitution, as well as elimination. We'll get that as well. But so step 1, step 2, step 3, step 4, those are very easily visible. You can read through those, but I'm going to go through the steps here as well, kind of, not necessarily writing them out, but just going through here. So substitution, we want to solve for a variable. Well, guess what? Both of the equations are already solved, so that's good. So now substitution means that I can take this right here and put it into this y, because this equation says y is equal to that. So instead of me writing y again, I'm going to write negative 4x plus 5 equals 3x minus 2, because we said that this is equal to y. and y equals 3x minus 2. So I can substitute it in. That's where the word comes from. So now I have negative 4x plus 5 equals 3x minus 2. So let me rewrite that a little bit clearer so we can see it. Let me solve for x now. I got to bring that over by adding it, 7x. Bring this one over here by adding it, plus 2 equals 7. I divide, I get x equals 1. So in my answer, this is basic skill work, not word problems. I'm going to get 1 comma something. I don't know what that something is yet. How do I find it? Well, I'm going to take this 1, plug it back into either this x or this one, doesn't matter, whichever one you want, and solve it out. So 3 times 1 minus 2 is 3 minus 2, which is 1. So 1 comma 1 is my answer, and that is it. I am done with that one. Okay, that's basically what step 1 was. It says solve for one of the equations. It's already solved for, so we're good. Substitute the expression from step 1 into the other variable, which I did. Substitute the value from step 2 into the original equation and solve. I did that. And write your solution as a coordinate pair. Boom, 1 comma 1. Man, 4 steps right then and there. All right, here's your second example. You can see this one here. Both equations are not y equals, but this one is a y equals. So I'm going to plug this into y in the first equation there. So I get 4x minus 8, parentheses, now what I plugged in was 5x plus 9 equals 0. So I still get the 4x. This is a negative 8 going to be distributed through both terms. Negative 8 and 5 makes a negative 40x. Negative 8 and 9 makes a negative 72 equals 0. Okay, let's combine terms. That's negative 36x. Let's add the 72 over. So negative 36x equals 72. X equals negative 2. Sound like a little robot there or something. I don't even know. So now let's plug that back. Let's plug that bad boy back into this x. Now, could I plug it into the x in the first equation? You could, but it takes a little longer to solve. You always want to plug this in back into the one that's like y equals or x equals. It's just easier that way. I'm trying to make your lives easier. It's like that little, I don't even know, that Staples easy button. This is easy. And it like you hit it and it's like, whoa, this is easy. Okay. So let's plug it in. We got 5 times a negative 2 plus 9. That's negative 10 plus 9. That's a negative 1. So answer, negative 2, comma, negative 1. Now, some of you might be like, well, what happens if I plug negative 1, negative 2 in? Like, say you get your answers, and these are your answers, but you write it this way. That's wrong. It's got to be x, comma, y. This is your only answer, and that's the only correct one you'll get full credit for. Please make sure you do that correctly. All right? Let's go into elimination. All right, with elimination, you still got 5 steps. Now you got 5 steps. It's okay. They go by pretty fast. So you have a couple different things we'll talk about as well, but these are the 5 steps. You want to make sure your x's and y's are lined up. I don't know why this thing keeps popping up here. Let me try to exit out of this sucker. Apparently my computer's got some viruses, but that's okay. You want to make sure your variables are lined up. Good. You want to decide which one to get rid of. That's where the eliminate comes from. You want to eliminate one of them. All right. You either add or subtract and stuff like that, and we'll go on as well from there. So let's kind of get going. Now, before we actually get through example 3 here, there are some different types and when to use it. So first is add or subtract equations. So this is the different type. You can either add or subtract. When is it best to use this one? It's best to use this one when equations can cancel by either adding or subtracting. Pretty self-explanatory. Okay, so basically what that means is if I look at the variables and I say, what if this had a 2 there? Could 2 minus 2 cancel? Like, they can cancel out, right? So that would be okay. I can do that. What about my 8s here? My 8s just cancel right now, right? Negative and positive. So I'm going to use adding. I'm going to add these two together, and I'll show you exactly when we use the other 2 examples here. So let's finish this one up. I'm going to add or subtract this one. Actually, I'm going to add them because negative 8 plus 8 is 0. My goal is to get a 0 for a variable. So I get there. X minus 2 is negative x. Negative 8 plus 8 is 0. They go away. You do not need to write any of it when they go away. Equals -1 plus 10 is 9. I got to solve for x, so x equals -9. Okay, and I got to divide by a negative, right? So x equals -9. So this is a little tricky right now because one of the variables is not solved for. It's not like x equals or y equals. So I got to plug this into either this x in the first one or in the second one. It's your choice. I like to use smaller numbers, so I'm going to use the bottom one there. So let's plug the -9 into x minus the 8y that I had equals -1. Let's bring this over. So it's -8y equals, I got to add 9, right? So it's +8. So y equals -1. So -9 comma -1 is my answer for this problem. So that's the first step. You can either add the two equations together or subtract them right from the get-go. If they cancel easily, you're good to go. If a variable is canceled, you're good to go. The second step is you can multiply one equation. What I mean by this is if you cannot add or subtract the equations to easily cancel a variable out, but you can multiply one of them to then cancel. So I'll give you an example here with this example 3. So say I didn't add my y's together because I either didn't see them or they are not actually right. I could multiply the top equation by 2, and then I get 2x minus 16y equals -2. And then I can add them together. So you can multiply one equation, then add or subtract. Okay, so I can get the same variables, then add or subtract, and then I'm good to go. The third step, and this is more the difficult one, but you're going to need this for when we have 3 variable systems on the last couple problems that we do, is you're going to need to multiply both equations. Multiply 2 equations, then add or subtract. So if you see that none of the numbers are able to add, and none of them you can multiply one to get the same, then you have to multiply both. And it's kind of crazy. We'll do some problems with that as well. But eliminations, I think it's a little easier, but you got to know multiplication. So let's go into some more examples here. All right, example 4. You can see that I can do two things. One is I cannot add them. Well, I can't do step 1, right? I can't just say, oh, I can add these up and I cancel x's or y's. Can't do that. So what I can do is I can multiply the bottom one by either 2 or 7. So your first goal is to find out what variable you want to eliminate. And for me, I always try to eliminate a variable that I don't have to multiply by a huge number. So it's either 2 or 7. And you see if I get 7, I get some bigger numbers. So I'm going to do 2. And let's do that. So here we go. I'm going to multiply the bottom one by 2. So I get the same first one, which is -20x minus the 7y equals 27. I'm going to multiply the bottom one by 2, so I get 20x plus 2y equals -22. And now I can add them together. So I get -5y, because my x's cancel, right, equals 5, and y equals -1. Now here comes the beauty about this elimination. You could plug the -1 in to find x to this equation, your original bottom one, or your original top one. But let's pause for a second and think about which one you might want to plug it into. That's right, I would probably want to plug it into the bottom one here because the variables are smaller, the numbers are smaller, so I should be a little bit faster with my addition and subtraction. So let's plug it in. I get 10x plus a -1, I plugged it in, equals a -11. 10x, I'm going to add this one over, equals -10, x equals -1. So my answer is -1 for this x, comma, -1 for that y. Okay, remember x, comma, y in that order. Hopefully you saw that wasn't too bad. Let's go to example 5. This is going to be kind of the tougher one. So I can't just add them because, again, I can't just cancel a variable. And you see that I cannot multiply the top one by a number to get 3, and I can't to get 10, I'm sorry. And I can't multiply this 3 to get 5. So I'm going to have to do the double multiplication. So multiply 2 equations. So let's think about this. 3 and 10, what can they both go into? They can both go into 30. And 3 and 15, they can both go into 15. So either I multiply to get 30 or I multiply to get 15. And for me, I would let's multiply to 15 because the numbers are smaller. So that means the top one is going to get multiplied by 5. The bottom one is going to get multiplied by 3. So now let's rewrite it. When I multiply everything. So 5 times 3 is 15x. 5 times 3 is 15y. And 5 times 3 is just equal to 15. Same thing on the bottom. Negative 30x plus what? Plus 15, y, equals negative 30. Now, if I add them, I don't cancel out my y's because they're both positive, so I'm actually going to get a bigger number, right? So I have to subtract. So I'm going to make a big subtraction sign there, and I'm going to explain what that means. Because I'm subtracting, my y's are going to cancel. 15 minus a negative 30. 15 minus a negative, that means positive, right? I have to add them. 15 plus 30 is 45, equals 15 minus a negative 30. 15 minus a negative 30 is another 45. X equals 1. I'm going to plug this 1 back into my original here. 3 times 1 plus 3 times y equals 3. 3 plus 3y equals 3. 3y equals 0, I subtracted, right? And then y equals 0. You can divide 0 by something. It's always 0. So my answer is 1, 0. All right? This is going to be a little difficult. You got to kind of work on this a little bit. Multiply both equations to try to get the smaller of the values. All right? Always choose the smaller ones. 3 variable systems. I can't get any more excited. You know why? Because these are going to be kind of dreadful. The reason why is because they're going to be kind of long, so hopefully you write small. I'm going to tell you to write small. I'm going to use all the space I can because then I can just erase it with a simple button. Like here's my work. Oh, boom, I can get rid of it pretty easily. Okay, I'm going to tell you to write small. If you need another sheet of paper, please use it. A 3-variable system is now 3 equations with 3 variables. Haha, RST or XYZ. Your answer is going to look like this. In this case, it's RST, so it's going to be R, S, T. Whatever variable comes first is X, and then Y, and then Z. Okay? So this one here is X, Y, Z. In that order, don't mix them up. So that was pretty easy. Now let's actually get to solving them. Here's the first thing I want to do. I want to label each of these equations A, B, and C. And the reason why I want to do that is because the first couple steps, I want you to understand what you're doing and what I am doing. I don't want you to get confused. That's the biggest part here. There are more than one way to solve this. I'm going to do it one way. I'm not going to spend the 30 minutes to solve them all 6 ways. Okay? If you want to solve it a different way, you're more than welcome to do so. But it's going to take me a little while to understand what you're doing. So it's going to take me about 4 minutes to figure out what you did wrong. So if you have a question, you're more than welcome to ask, but it's going to take me a little bit to figure out your answer. Okay, here we go. Again, I want to take 2 equations. First thing I want to do is take 2 equations and try to eliminate a variable. I'm going to use elimination for these. More often than not, I'm going to use elimination. Okay? So if I take A and B, can I eliminate my R's? Well, yeah, I can. So what I'm going to do, I'm going to take A and I'm going to add it to B. Okay, so A plus B. So I'm going to take A, R plus S minus T equals negative 4. I'm going to take B, which is negative R, minus 6S plus T equals 24. Now I'm going to add them together. R's are canceled. 1 minus 6 is negative 5S. Negative T plus T, oh, those are canceled too. That makes it really nice. That equals what? Equals 20. I can solve for S because my T's and R's canceled. I already know what the answer is. S equals negative 4. So in my answer, remember I have RST. I know S is already negative 4. It's not always going to work out that nice. It just happened to in this problem. Okay. Let's then take A plus C. Why? Because R minus R cancels. You have to choose 2 different equations the second time around. I chose A and B the first time, so now I'm choosing A plus C. You cannot choose A plus B again, otherwise you're going to get kind of infinite answers, and that's not going to work. A plus C, here we go. R plus S minus T. Ooh, that looks like an E. That looks still like an E. I guess that looks better. I don't know. Equals negative 4. And then negative R minus S plus 4T equals negative 11. Let's solve. R minus R, add them, gone. S minus S, gone. I have negative 1. Negative 1 plus 4 is 3T equals negative 15. T equals negative 5. That was pretty easy. This is an easy one. Man, I shouldn't have done this one. Oh, the next one's you're gonna really hate me on the next one. So now what? I have S and T. I can plug it into this equation here and solve. R plus negative 4 for S minus negative 5 for T equals negative 4. That's R minus 4 plus 5 equals negative 4. R plus 1 equals negative 4. R equals negative 5. So my answer is negative 5 for R. So this is my answer for this one here. Okay, that was an easy one, so I started you off really easy. Example 7, it's going to get a lot harder, and you're probably going to want to go cry. It is okay. All right, example 7, I want to find two equations that cancel with the same variables. So let's look at, remember these are A, B, and C. If I look at A and I look at C, do they have a y in common? Right, so I can subtract them. So let's do it. A minus C. So A is negative 2x plus 4y plus z equals negative 16. C is negative 6x plus 4y minus 2z equals 22. All right, I'm going to give you a little shortcut. Instead of putting a big old subtraction here and forgetting to do it, here's what I suggest. Anytime you subtract equations, flip the sign of every term in second equation. That's a little shortcut. Okay, here's what I mean by that. So instead of having that big subtraction side, because I'm subtracting, just flip the sign of everything in the second equation. So plus, minus, plus, minus. If they were all pluses, then all be negatives. If they're all negatives, then they're all pluses. Just change them and then add them up. I'm sorry, I should say add them up. Add them up. Okay, easy, easy, easy. Negative 2 plus 6 is 4x. Y's are gone. 1 plus 2 is 3z. Negative 16 minus 22 is negative 38. See, that wasn't so bad, was it? All right, now I need two other equations. Remember, I cannot use A and C, so I can either use A or B and C. But let's think about this. I want to get rid of y's. I got to get rid of the same variable. So I have 4 here and 6 here. Or I have 4 here. So really, it doesn't matter which one I choose. I'm going to choose A and B. So A, I can't multiply 4 to get something to 6, but I can multiply them to get 12, right? I can multiply to get 12. So I'm going to take A, and I'm going to multiply A by 3. So 3 times A, okay, 3 times A, so let's do that. So I'm multiplying all of this by 3. Negative 6x plus 12y plus 3z equals negative 48. Then I'm going to take the second equation, and I'm going to multiply that by 2. So that's negative 10x plus 6y. I'm sorry, not 6. This is what you're going to do. You're going to forget to multiply, just like I did there. So let me erase that. There we go. Plus 12y minus 8z equals 38. Now, these are the same, so I have to subtract them. So minus 2b. But remember what I said about subtracting. I can switch, 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 or flip, 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 whatever you want to use. Switch or flip, same thing. Now let's add them up. Negative 6 plus 10 is 4x. Those are gone. 3z and 8z makes 11z. And then negative 48 and negative 38 makes, oh man, a negative 86. This is pretty cool. All right, that's the first part of 3 variable systems. And that sucks, but it's okay. All right, now what do we got? We got 2 more equations. We have this equation here, right there, and we have this one here. Now let's solve them. Okay, I'm going to stack them. So I get 4x plus 3z equals negative 38. That was right here. And then I get 4x plus 11z equals negative 86. And that was this one over here. Now, if I look at them, how do I solve this? How can I live without three variable systems? Very easily, actually. Remember, I can subtract now. So let's subtract them. Remember, change, change, and change. Now let's combine. The reason I can subtract them because 4s and 4s are going to cancel when I do that, so they're gone. 3 minus 11 is negative 8z. Negative 38 plus 40 plus 86, I'm sorry, is 48. Z equals negative 6 when I divide. Pretty simple, okay? So I know z, x comma y comma z is negative 6. Let's plug the negative 6 back into one of the original equations here. Let's get our x value. So I get 4 times x plus 3 times negative 6 equals negative 38. I know this is kind of like repetitive and kind of boring and tedious, and you're right, it is. When you higher level math, you'll learn how to, this is actually a lot easier, but right now we're going to do basic. So I get 4x minus 18 equals negative 38. I get 4x, I'm going to bring the 18 over, that gives me 20, negative, and then therefore x equals negative 5. How do I get the y value? I'm going to go back into the original equations. Let me erase some of this stuff here. I'm going to go back into the original. I'm going to go back into the first one because the numbers are smaller. So negative 2 times the negative 5 plus the 4y, we don't know what y is yet, plus a negative 6 there for z equals negative 16. That's a positive 10 plus 4y minus 6 equals negative 16. 10 minus 6 is 4 plus the 4y equals negative 16. Minus the 4, I get 4y equals negative 20. Y equals negative 5. So negative 5 is my answer for this three variable system. Yes, please don't give up. It's okay. Power through it. I know, but you got to do it. Okay, you're not going to have that many problems on the power assignment. There'll probably 2 of these, maybe only 1. I don't even know. I'll probably change it. There might be only be 1 of these, but you got to get it right. All right, you cannot miss this problem and pass the power assignment. Let's get on to the last 2 examples here. Last 3. I can't count. 1, 2, 3. Man, I have a hard time counting today. All right, let's add these up. Let's add them up. Let's add them up. If I add them up, I get 0 on the left-hand side. There's nothing there, right? Cancels and cancels. That means that I got a 0 there. Equals 4. Does 0 equal 4? No, not ever. So when that happens, it is a no solution. These are special cases, meaning it doesn't happen often, but when it does, you gotta know when it does happen. Okay, so I get no solution for that one. Example 9. Let's subtract these. Remember, when I subtract them, I get change, change, change. So I get on the left-hand side 0. On the right-hand side, I get a 0. When that happens, I get either, there's 2 answers, and I'll accept either of them. One is all real numbers, or if you want to be more like crazy, it's infinite solutions. Okay, either one of those answers I will accept. You only need to write down one of them. Don't write down both. If you put all real solutions, I might be okay with that, but that kind of looks bad, but I might have to be talked into it. But let's just use those 2 there, and we're good to go. That's when 0 equals 0. On the left-hand side, when 0 equals a number that's not 0, so when it doesn't match, it's no solution. Example 10, we have a 3-variable system there. Let's do some math. Let's do some math. I'm going to take the A and C and add them up, A plus C. Instead of writing it all out, I'm just going to do it real quick. I know the R's are going to cancel, so that's good. Negative 3 plus negative 2 is negative 5s. And I know that do the same thing with my T's. That's negative 5t equals 19 plus 6 is 25. So that was A plus C. That was pretty easily there. Then what I'm going to do, I'm going to multiply b times 4 and then add it to a. So a plus 4b. Okay, so I'm going to write this one down because I need to understand what this is. So it's 4r, this is a, minus 3s plus t equals 19. Multiply b times 4, I get negative 4r plus 16s multiplied by 4, that's 12t equals negative 84. Now I can add them up. I get, what do I get there? Negative 3 and 16 makes a 13s, makes a 13t, and then 19 minus 84 is negative 55, negative 65. There we go. That's cool. Okay, so negative 65 there. So what am I going to do? I'm going to take this one here, and I'm going to take this one here, and I'm going to put them on top of one another. So negative 5s minus 5t equals 25. I get 13s plus 13t equals negative 65. So I need to multiply both of them by something. I need to multiply the top one by 13. I need to multiply the top one or the bottom one by 5. So when I do that, I get negative 65s minus 65t equals 13 times that is 425, I think. I'm kidding, 325. I can't do my math today. 325, there we go. Let's do the bottom one. I get 65s plus 65t equals 325. Let's cancel. Add them up. Cancel, cancel, cancel. So I get 0 equals 0. What did we learn from before? When I have something equals something that are the same, I get all real numbers, or infinite solutions. Okay? So if the variables cancel and each side of the equation is equal, that means that like 0 equals 0, or 2 equals 2, or 1 equals 1, or 100 equals 100. Then there is infinite solutions, or all real numbers, right? Remember that was the other one we used. If the variables cancel and each side of the equation is not equal, like 0 equals 2 or 1 equals 7, then there are no solutions. We got to remember that. Okay? All right, that is it for this video. I know it was kind of long. I'm sorry. I get to talking, and I love math so much, But you should be good to go. That's 3.1. Good luck on your power assignment, and take notes, do work, and you'll be successful.